Okay, today we are going to be looking at stormwater pond calculations, specifically the riser design and the stage storage discharge tables. For this example, we're going to be using hydroflow. Hydroflow is used in about 80% to 90% of the stormwater submittals that I've reviewed, so that seems most logical to go with it. The first thing I would look at when reviewing the pond reports, and remember some projects can have multiple ponds and multiple pond reports in the calculations, so make sure the one you're looking at corresponds to each other. But the first thing I would like to do is go in and scale the bottom of the pond and make sure these contour areas are approximately correct. As you know, ponds can be shaped irregular, so scaling them out can be difficult to get exact, but just go to the engineering drawings where the plans are scaled and then get your engineering scale and approximate it the best you can using just 2 or 3 minutes of scaling those out. If the numbers work out, then you can move on. I guess the other thing I would say on that is if these stage storage discharge or stage storage information is provided anywhere else, such as in the detail of the pond, make sure the model correlates with the numbers used in the detail or the engineering drawings. Now moving on to reviewing the riser and the emergency spillway for the pond is what we're going to do now. Before we do a little example, I want to explain what each of these values mean that I'm highlighting here. So A is always modeling the pond's outlet barrel. So that's the outlet leaving the riser. B is orifices in the riser. And the first one is the lowest elevation, so it's usually the low flow orifice. C is the next set of orifices in the riser that are above the low flow orifice. And then the engineer could also add D if there was another stage at a different elevation in the riser. For the weir structures, A is the circumference of the riser. Circumference, not diameter, and it's in feet. Some junior engineers can mess this one up if they're not very familiar with hydroflow, so be very careful to check A here. B is typically the bottom width of the emergency spillway. C is the width of any weirs in the riser, like a rectangular or V-notch weir, and it will be noted as the weir type down here, so this one is rectangular. So that's what each of those are, and there can obviously be additional risers there, D, E, and so on. So that's what each of those mean. Now moving on, we'll do a quick example. First, looking at A, which is the outlet barrel, we're going to see if it's 30 inches at an elevation 824, invert elevation 824. Okay, so now we're looking at the detail. Okay, so now we're looking at the detail for the calculations we were just reviewing, just looking at a second ago. First thing to note is for this specific project, they have included a during construction riser detail and a post-construction riser detail. And this is what I prefer as a plan reviewer, and typically I think this should be provided. But obviously we're going to be looking at the post-construction riser detail since we're looking at the post-construction hydraulic calculations. So we're looking at the outlet barrel and we're seeing if it was at a 30-inch RCP at invert elevation 824, and that is correct. Some other things to note from the calculations: it was 64 foot in length at a 4.69% slope. So reviewing the outlet barrel, and on the plans it is also shown as 64 feet at a 4.69% slope. So all of the outlet barrel inputs are modeled correctly. Now moving on to the low flow orifice. It's 4 inches at an elevation 824. We're actually not going to review that one on the plans. The engineer has kind of a trade secret with how they do their low flow orifices, so I can't show it on the plans. But moving on to the weir, there was no other staged orifice, so we're moving on to the weir now. A, that would be the circumference, and a 12.57, that correlates to a 48-inch riser. So that's what you would want to check, that it is a 48-inch riser. And as we can see here in the plans, and it's shown in multiple areas, it is a 48-inch riser, and that's the inner diameter again. Okay, the next thing to review here is B, and again that was the emergency spillway. So it should be a 30-foot length emergency spillway, and the bottom elevation should be at 833.5. I'm going to move back. I don't like to do this, but I did not review the crest elevation, and that's the top elevation of the primary spillway. So the top of the riser should be at 832.5. Switching over to the detail, as you can see, the top is 832.5 as it was modeled, so everything is correct with the riser. Well, we haven't reviewed the weir yet, but so moving on, the next thing to review here is B, and that again, that's the emergency spillway. So now looking at the detail for the emergency spillway, it's shown as 30 feet wide at an elevation of 833.5, the bottom elevation 833.5, and the bottom elevation is typically defined as the top of the rock, which is shown here. 833.5, and it's 30 foot wide, so that is the emergency spillway is designed correct. The last columns here is for weirs in the primary spillway and the riser. So it's showing a 3-foot weir at 831. Back to the detail for the post-construction riser, we'll see that there is indeed a 3-foot wide rectangular weir with a invert elevation of 831.